Hello everyone, welcome back to the channel where we're going to keep on excelling with our college algebra unit. Alright, this is the third video of the series and of this unit, and we're taking a look at something different. So not really just plain old algebra as the first two videos were. We're talking about numbers, and more specifically complex numbers. So I think one thing I should introduce you is what is a complex number. And to do this, I'm not going to use the paint tool, I'm just going to use text. That'll make things a lot easier. So are what are complex numbers? As I can type fast, y'all. What are complex numbers? So basically, let's go ahead and answer that with some more text. All right, right over here. So complex numbers are imaginary numbers. I don't care about the spelling. I'm gonna say, for example, I is the square root of -1. And for some basic information, I squared is -1. I cubed is -I, and I to the power of 4 is 1. And then it repeats all over again. Alright, there we go. That's basically it. That's a little introduction on what are complex numbers. So you can take a picture of that, I guess, if you want. My very bad explanation. Okay, anyway, that's it. So we're actually going to start the math part now. So I think hopefully that cleared any doubts that some of y'all may have had. Okay, so let's go ahead and do this. Let's begin. Okay, so let's say, for example, I have the number square root of -49. Right? How can I rewrite that? Well, you could obviously say that's the square root of -1 times 49. Which you can say, okay, so I know the square root of 49 is 7 times the square root of -1. Okay, but this, what is this? What is the square root of -1? So you may have always learned that you can't have a negative inside the square root, right? Because, and it's for good reason, right? Whenever you square something like 5 squared, you can get 25, right? But if you take something like -5 squared, you're still going to get 25. Unless you're squaring the whole thing. It's still going to get 25, right? So that means that anything, when you take the square root of 25, the answer is 5. Square root of 25 is still 5. Unless, of course, we're talking about like equations or something. But generally, we go for the positive answer. But yes, of course, there's a negative option as well. Point being, you can't have a negative under the square root. So you can't really have this. But unfortunately, we need something to represent it. I don't know why, but imaginary numbers do exist. And they're called imaginary because they're not real, but for reasons we have them. But obviously, there are good reasons, of course, why we have them. I know that they're used, there are applications of imaginary numbers. Obviously, they're really important. Obviously, they weren't really thought of as really useful until people realized, okay, we need them. So yes, this will be 7i. All right. So 7i is what you can represent that as. All right. Why don't you? I'm gonna give you all a problem, and you do the next one. And it's not gonna be a hard problem. It's gonna be a very basic problem, probably not as easy as mine, but easy enough. You can do it. Or simplify this. Square root of -20. Pause the video and do it. All right. Here's how I would do it. So I would say, okay, well, 20. What are some factors of 20? I want factors of 20, which I can take the square root of 4, 4, and 5. And of course, the -1 can stay there. You know, I can take the square root of 4 is 2, and then 5 just stays there. And I can take that outside. So it's 2i times the square root of 5. All right. That's what y'all should have gotten as your answer. All right. Let's move on to another problem, which I will go over with you, but you can do this on your own if you would like. Is let's say we have the square root of -15, and I multiply that by the square root of -15. Okay, well, I know this is going to be I times the square root of 15 times I times the square root of 15. So I'm going to get I squared, which is negative 1, and the square root of 15 squared is going to be 15. It's negative 1 times 15, which is negative 15. Negative 15 is the answer. And obviously, you're doing the square root of negative 15 twice. What else do you expect? Alright. Let's go on to this one. Alright. This one says, okay, so we have the square root of negative 40. And I'm going to multiply that by the square root of negative 5. Again, we do the same thing. So we have I times the square root of, I'm just taking the negative part, taking care of first. And I'm going to find factors of 40, obviously, which I can take factors of and stuff. So 40, and what's 40 times 5? I'll do that part right here. 40 times 5. That looks like 200, right? 200, so I can write that as 100 times 2. 10 I. Oh, sorry. So then I square that because I and I. So 10 times negative 1 times the square root of 2, which is negative 10 root 2. Yeah. There we go. Negative 10 root 2. Alright, making sense, y'all? Alright. Then let's go even harder. Not really. Again, this isn't terrible math. You may have learned this sometime in your life. Let's try this. Negative 20 plus the square root of negative 50 all over 60. I'm only going to concern myself with the part on the right and forget about the part on the left for now. This is already a good number. So this is I. And then I know, well, 50 is just 25 times 2, right? So the square root of 25 is 5. So I get 5i times the square root of 2. Okay? So now let's bring it over here. So this is negative 20 over 60. I'll break this up. Plus 5 times, or 5i times the square root of 2. Okay? And all over 60. All over 60. Negative 20 over negative 60. That's negative 1/3. Negative 1/3. Plus, and then 5 over 60. Well, I should forget about that for now. Let's write the I root 2 first. So 5 over 60 is the same thing as 1 over 12. So it's just this. Okay? And I think, what am I thinking of? We can take this under a common denominator if you want, right? We can definitely do that. We're going to get another common denominator of 12. If I multiply this by 4, I'm going to get negative 4 here. Plus I root 2. Okay? So that's a way of answering this problem. Alright? Negative 4 plus I times the square root of 2 all over 12. Okay? But if you want it in a more simplified form, then I would say go ahead with this solution. So it just depends how you like it to answer this problem. I might go with the left one, but if someone says, hey, put it under a common denominator, then that's how you could do it. Okay? So yeah. Alright. Let's do a couple more questions, and I think we'll be good, y'all. Oh, where's my razor tool? There it is. Okay. Let's do this problem right here. Okay, so now we're going to look at multiplication with complex numbers, all right? So we're going to have 8 plus I times 8 minus I. Okay? I'm going to multiply them together. So you think of this rule as A plus B times A minus B. Think about it like that. And the rule states that a plus b times a minus b is a squared minus b squared. In this case, we're going to get our a is 8 and our b is I. So we're going to get 8 squared minus I squared. So 8 squared is 64 minus I squared is negative 1. So we should get 65. Alright, 65. Alright, and yeah, that's it, Shield. Let's go ahead and move on to a couple more problems. And I think I'll get the hang of this soon. Alright, I think complex numbers are alright. They do appear a little bit on the SAT and ACT, so it's something just good to know. Alright, let's take a look at division now, which will, I think, be like one of the last things you should know. Let's take a look at 9 plus 8i all over 7 plus 3i. And I'll explain what to do. If you know what to do, go ahead and solve it. But if not, I'll explain it. So we're going to multiply this by the complex conjugate, which is basically the opposite of this, alright? And we're going to do this for a good reason, of course. Never really think for the wrong reason. I'm going to multiply the top and bottom by 7 minus 3i. And this all makes sense soon. Or once you do it the first time, I think you'll understand why we're doing it, without me really having to explain why we're doing it. Okay? If you've taken other algebra or any other sort of math, you'll know that we have to do this. Let's do it. On the top, we're going to get... and let me explain why, y'all. So the rule basically is you cannot really have a complex number in the denominator. It just doesn't make sense. Like something over the square root of negative 1. You can definitely have I in the numerator, right? We're still probably going to end up with that answer, but we won't have an I in the denominator because it's just not allowed. Alright, we're into the math laws. So let's multiply the top. So 9 times 7, that's 63. Okay. And then I want to multiply the i's. So let's do 8i plus 7i. That's plus 56i. So I'll write 56 over here. And because I want to look at the other number. So 8. So we're going to have 56i over here. And we're going to have right here minus 27i. So let me do minus 27 right here. So 56 minus 27. So 16, 7, that's 9. This becomes a 4, so 29, I believe. Yeah, that seems about right. 27 plus 29 is 56. Okay, and yeah, that's about it. So yeah, it was 56i right over here, and minus 27i. Okay, so plus 29i, and it's 8i times negative 3i. So that's negative 8, 16, 24 I squared. Right, 8, 16, yeah, that's 24. It's negative, and it's I squared. This becomes a plus 24. Plus 24. Okay. And we can rewrite that. 63 plus 24. Let's see, 7, 8, 87. Right, 63 plus 24 is 87. And yeah, I basically took care of this and this. So it's 87 plus 29i. And then on the bottom, so multiplying these together, so 7 into 7, so that's 49. And then minus, so basically, yeah, minus b squared. Okay, so it'll be minus 9i squared. Minus 9i squared. So plus 9. That's about it. So we get 87 plus 29i all over 49 plus 9. That should be 58. Right, 58. Okay. And we can simplify that a little bit. Okay, so 87 over 58, that's 3 over 2, plus 29 over 58, that's a half, so I'm going to write that as I over 2. So you can rewrite that as 3 plus I all over 2 if you want it under one common denominator. Alright? But if you don't want it, you can write it as 2 separate fractions. Alright? Just different options and getting the same answer. Alright? Okay. Let's go ahead and do 2 more problems and then we're done. Because I know y'all are just having so much fun with these complex number problems, you want to do them on your own. Okay, so remember what I told y'all about the i's? What's I to the power of 17? Remember how I said it repeats over and over again? What's 17 divided by 4? Because that's when it becomes 1, right? So that's 4 minus 16, and we're left with 1. Your remainder is what, whenever you find your remainder, you're going to put I to that power, and that's your answer. I to the power of 1, which is just I. If that's 16, it's going to become 1, and then at 17, it's going to become I again. So the answer should be I. Alright? And last but not least, I'm going to take a look at this one. Alright, pause the video, do this one on your own, have fun with it. I to the power of negative 9. Okay, you're like, what the heck is this? Well, if you have I to the power of negative 9, well, there are a couple things you could do with it. I would multiply by I to the power of 16, because that's 1. And that's something but I to the power of, and then 16 minus 9, 10, 11, 12, 13, 14, 15, 16, I to the power of 7, right? And I to the power of 7, well, let's see, 7 minus 4. Your remainder will be 3. So it should be negative I. Okay. Negative I is the answer, and that's it. Alright. That is the end of this video, and it looks like, I think, the end of Unit 1. I'll see what else is there, but yeah, thank you guys for watching, and I'll see y'all next time.